myself, Eleonora Vargas Solar. We are co-chairs of the diversity and inclusion activities, and we are delighted to have Mercè Crosas keynote today. The title is A New Computational Social Sciences Program at BSc with open data and reproducibility in mind. Before I give you the floor, I will introduce you through your CV. So, Mercè Crosas is a researcher and technologist currently at the Barcelona Supercomputing Center with accessible, interoperable, and with expertise in data sharing, data science and analysis, data management, and open and fair data, applied across multiple scientific fields from social sciences, health, and natural science. Dr. Crosas spent most of her professional life at Harvard University, where she was PI and co-PI of over 15 research grants in these areas of expertise, and contributed to creating research data repositories worldwide by co-leading an open source platform for sharing data, like databis.org, building research tools for text analysis and for handling and analyzing sensitive data, the openness.org. And these for social sciences, as well as building automated workflows for data provenance and computationally reproducible research, and overall enhancing the use of data and computation for scientific research more openly and responsibly. Since early 2023, Dr. Crosas is the head of the Computational Social Sciences program at the BSc, a new program that aims to facilitate the use of vast amounts of data and computing to help transform research in the social sciences and digital humanities. Before this position, Dr. Crosas was the Secretary of Open Government at the Catalan government from 2021 to 2022, where she was responsible of open data, transparency, and civic participation. Prior to that, she was Chief Data Science and Technology Officer at Harvard's Institute of Quantitative Social Sciences and the university-wide Research Data Management Officer. She also led the development of data systems in biotechnology companies, and earlier in her career conducted research and built scientific software in astrophysics at the Harvard Smithsonian Center of Astrophysics. Dr. Crosas holds a doctorate in astrophysics at Rice University, and funded by the Spanish government, and she has a degree in physics from the University of Barcelona. Thank you very much, Mercè, for joining us at this committee.
Thank you. Thank you, everybody, and thanks to the organizers for inviting me. It's a pleasure to be here. And today, I'm going to talk about this new computational social science program, a completely new program that starts not only at the Barcelona Supercomputing Center, but that it's new in any other supercomputing centers in Europe. So there is usually in computational research and supercomputing centers, there is more work related to physics, to my prior training, right, to material sciences, particle physics, to climate change, to biomedicine, but less in social sciences. So this is quite new, although there is work on computational social science that has been happening in the last decade by many social scientists. So, and it's great to be as part of this conference too, because most of the last decades of my work has been related to the data, to research data, working on enhancing the use of research data and managing data, but also creating repositories to make more data accessible for research. So data are the center of my talk and what I've done for for the last 20 years or more. And obviously, in a database conference, I feel that I fit, and I'm happy to be here and share what we've done. Although I'm sure they will be from a different perspective than what you're used to. So first, I just thought that to talk briefly about the social sciences and a little bit of the history on the data that has been used in mostly in quantitative social sciences, and also the models, the methods that have been used, the history of that, just to give some context on why this program now. But then I also wanted to discuss the work that I've done on open data and also in data privacy when the data cannot be open, and reproducibility of research, and then fit it all into this new program. So part of the talk is also part of my trajectory in a lot of the work that I've done in the last decades, and giving it some sense, although I've been working from physics from many disciplines to biotech and also social sciences. But I think, and you might find too that all of it makes sense in some way, because there is always the data, the models, the computation as part of it. So social sciences, I'm sure, I don't doubt that you know what it is, but on the other hand, there are many definitions, and some people think of include some disciplines and some others. So I'll just review a few of the definitions from, for example, from the Library of Congress, where they have the topic, the topics and classification of taxonomy that they use for a lot of the sciences. So they include in social sciences, perhaps the main disciplines are anthropology, economics, geography, history, political science, psychology or cognitive sciences, social studies, sociology. But it is a lot more than that. There are 50 subcategories. I couldn't put here the entire list, but if you go in the category that is defined in Wikipedia for Library of Congress, you will see all these subcategories. So it's much broader. I just said that because joining, for example, the BSc, where a lot of the departments that exist now are in computer science, life sciences, many of the people thought that it was only about social study, sociology when we talk about social sciences, but it includes a wide range of disciplines. If you look at the European Commission, they join social sciences with humanities. So in some way, the program that you will see, the scope of the program plans to include also the digital humanities. But within the social sciences, the broader categories are social and behavioral sciences, educational science, journalism and information, business and administration, and law. So that's quite, again, a wide range of fields within the social sciences. And in addition, it has the humanities, right, which then we have many more disciplines that some of them are starting to use a lot more data and digital data, right, to do the analysis, the studies, and to improve scientific inference. So that give one more summary of what Wikipedia describes, as the main categories or fields within social sciences. And I don't need to read you all these lists, but again, to see what we're talking about when we talk about social science. And in part, I'd like to make that point, in part because I can see with some of my colleagues, well, it helps to educate that sometimes they haven't worked on it, so they don't have a good understanding of what it is, but also to make the point that how relevant social sciences are now in the world today. Practically everything that you want to do, even if you want to build databases, even if you want to work on cosmology or any part of our day-to-day life, the individual level and the social level, the political level, right? Has one part of relationship with others, has one part of being part of I mean, sometimes all the relationship is with yourself, but that's and that is important too, right? But understanding that in order to achieve a goal is important, right? How do we work together? How teams form and work better, more productive, how we collaborate more? So those are questions that social scientists might ask, right? And then other ones about, well, we have the challenges of climate change or of health issues, but how do you implement that into a society? How implement the changes, the solution to society? So there is a big part of social sciences that are critical to a lot of our research, our studies, and our well-being now in the world today, complex world today. And it's by nature very interdisciplinary in some way, because it's hard to separate psychology from topics about being as part of societies. Hard to separate political sciences to some of the other fields in economics, in education. So they need to work together, even though the fields are still defined quite vertically. So, okay, that's now the social science definition, but then what are the data models to give more context and a bit of historical perspective that have been used in social sciences? So first on data, I mean, we can talk about quantitative social science or qualitative social science. Qualitative social science also use data, and I'll refer to both of them. But one of the bigger differences for quantitative social science have been the statistical offices or the statistical data at the nationwide registration levels that in fact started millennium ago, right? 3800 BC with the first census that it's been cataloged, because it's been found. So that there was already an idea that the importance of understanding who's the population and some characteristics about the population to be able to make decisions, right, about your in the case of the empire civilization or a city or region. But more in a more serious, systematic way, then in the 1600s, it starts to get has to start to get registered in some way databases, right, of populations. For example, in Germany, as far as it's one of the first places where there is this local registry of citizenship. But soon after, there had been started to be the case in several other countries and regions. So the first modern census is said to be in Quebec, in Canada. And in the 1700s, there is more systematic follow-up, whether it's every year, sometimes every 10 years, but just already designed for getting statistics and so. And every time more and more, to the point that now almost every country has a census, has a statistics office, and it's a very important for a lot of the work in quantitative social sciences where even if you gather other data, if you have surveys, if you have we'll see the data that are used now, that it's much broader when we talk about big data, but even that you often compare, right, with the statistics, with data from the population. So that's been always important to part of the access to that data, and as openly as possible was a very important part for making social science advance, and in that case for quantitative social science. At the same time, for qualitative social sciences, there's a lot of the literature, from the historical text to books to the interviews, and so that also obviously are used as data for that field, but here I was focusing more about the repositories or archives for quantitative social science. So there is in parallel this other line where So data archives and repositories, the name of all those spaces of infrastructures for making data accessible has been changed. I don't have here a slide, but in some other talks that I talk more about data spaces, data archives, data commons, data lakes. You've heard of all these terms, right? And sometimes they're used loosely in social science. The original repositories for data are the typical data archives, right? And as you know, you talk to some librarians, data librarians. So the archives has a very specific meaning, and that it's very it has to be very rigorous, right, in terms of how many copies you make of the data, right? If there is replicated in different locations, well, you know a lot of that. But so those definitions keep changing. But the one that I use more commonly now is the repositories and data spaces, in the sense that first a repository as not only just the database of the data set that has the data, but all the infrastructure and all the tools around to be able to share the data, to set licenses to the data, to set the metadata, define the citation. And I'll talk more about that, but I mean, I'm defining about a whole umbrella of functionality and tools around a database. At the end, you might have a file structure, a set of files stored in different ways. So you have a set of multiple databases that are part. Each one is your data set. It could be the way you store could be in multiple ways, but I'm talking about that layer of making that accessible to the end user, right? So anyway, for these data cards and repositories, I'd like to point out within the social science that the importance of the Odom Institute, and one of the institute in the University of North Carolina that was at least as far. There might have been some other institutes that we don't, they came and went and they haven't persisted for so long, but this one has continuously, still exists today, right, as an institute for research in social sciences, and started to gather data, a lot of data related to surveys already in 1924. Then in 1947, the Roper Center, you might know, for also the first social science data archive. Then the CPSR, the University of Michigan, right, that has a lot of data, not only quantitative, but qualitative data on social sciences. The UK Data Archive. In the 70s, there's the ISC, the Institute for Social Science, international scientific group or community. And then there was the origins of what is the CES, for the social science consortium of here in Europe, that now is focused, that now it's one of the ERIC, one of the infrastructures, the European infrastructures for dedicated to social sciences, and it's focused a lot on data for social sciences. There were other archives in the 90s in the rest of Europe, and I point out the one on Harvard database because my team worked on it, and we together with Gary King, and I led that project on. I'll describe a little bit more later on, but it's an open source platform that originally was focused on social science data, to be able to share social science research data and make it more accessible, more the help for reproducibility of research, make it reusable to build on. Scientific studies from data that have been already used, right? And at the same time, that platform harvests the data sets from all these other archives, so you can centrally find the data sets with all the same metadata, be able to cite it or find the location and so on. Well, and as you know, in the last decade to 20 years, right, more of the social sciences have started to use data from just any data from the web, structure, text data that is converted into quantitative data sets, right? Or sensor data, or satellite data, or in general just big data that to do some of the research. So, but as we know, data not everything, and social science, even scientific inquiry, scientific inference, provide you with the data analysis, and I point out here a book that has recently come out, but it's an introduction, but it is nice for teaching and introduction courses in social sciences that use data analysis, because it goes into, it's mostly using R. So obviously there is people use Python or that they would have more machine learning models too. But in this case is to use, well, different examples, real data with real data and real research examples to do the analysis, to measure, predict, and ultimately explain some problems in social sciences, and using all the applied methods that have been developed with the statistical community, but for social science problems, right? At the same time, I mean, this is all been very close to my trajectory. This is the people that worked on this book were also part of the, well, affiliated with the Institute for Quantitative Social Sciences at Harvard, and there's a team, one of the teams that I was leading within the institute was for a data science, well, sort of data science for social scientists that have developed this book. So at the same time, recently contributed to a study by the National Academy of Sciences in the US that was to do an evaluation of how much we can accelerate the scientific discovery by building more AI and machine learning tools that help to go from the model to the data. You know, I mean, when you have a science that and we would say infinite loop from model to data, to as you get more data, you improve the model to explain the data, but essentially to explain the part of the world that you want to explain. And there are some of the tools that are used to understand more what kind of experiment I could design based to go to model to what data I need, right? So for data acquisition, but then also obviously from data to model to improve the model as you get more data. So, well, this discovery loop is described in this study, this report from the National Academy of Sciences, if you're interested. But when we talk about social sciences and we work with data, at the end, it is important to me to not lose that there is the science in social science, right? What makes it scientific? And being scientific, it's part of what we want to do, whether we do qualitative research or quantitative research. This is a matter of style, of how you're going to approach your research, but in design, what you want is to follow a scientific approach, right? And what does this mean? I learned a lot of social sciences from Gary Finn and Sidney Verba from Harvard, that were part of the institute where I was at. And in this book, they define what I agree with what makes social science scientific. So it is first to understand that the goal is inference, whether it's descriptive or explanatory inference, but this is at the end what you want to get, right? So you do this scientific research, designing it in a way that you want to make descriptive explanatory inferences on the basis of this empirical information, right, about them. Also that the procedures, the methods, the code are public. Right? This makes it scientific that others can assess the validity of your work, of reliability of your work. So this verification is important, and that's what I'll talk about, reproducibility. And then the conclusions are uncertain. So whoever tells you you have a method and data and you certain, there is no error, no uncertainty estimated for the results that you're getting, and it's would be hard to believe, or at least we would not believe it as scientists, right? And at the end, the result we do, whether it's for all the fields that I show you in social sciences, it doesn't matter what field or whether I use animal sciences, so, but it's about the method, right? And that was already said by Carl Person in 1992. So, well, based on that, understanding that we do the science in social science, so there's been decades, 50 years of models and advancing in methods for social scientists, right, to be as creative as possible to get it from what it is a very complex set of disciplines, because I often something ask, I come from physics and don't take it as a complex field and hard to get to and hard to understand some areas of physics, but at the same time having gone through many different fields in science, in some ways social sciences are the most complex because you have so many variables with a lot of uncertainty, with very difficult to establish mechanisms of relationships among them, and there's not a theory that can help you connect all of them that you can test easily, right? So the development or the design of these methods and models have been essential to advance social sciences, and it's been done a lot with statistical expertise and all the way from models that are more region-based modeling, regression modeling, causal inference models, etc., or the structural equation modeling, etc. But at the end of the day, most social scientists still use most of the time linear regressions because in some way, because it's easier to use, it's a big part of it, easier than anything else. But a lot of the questions that are asked is still the first step is to do a regression to get to it. Although, of course, more and more there is machine learning, some other predictive models applying to social sciences, but they'll say you have to be careful about them, what you infer from that. So for causal inference, right, why social sciences? So it's the end is the motivation for a lot of the research in social sciences, and from the main things that you would ask about the world around you, right, is does X cause Y? If X causes Y, how large is the effect of X on Y? Is the size of this effect large relatively to the effect of other causes of Y? And this is how the book on causal inference counterfactual by Morgan and Winship starts, right? And that's simple, but it's very important and profound, and it's very difficult to actually figure out. I mean, one of the examples that I keep using during the book, and it's an example that is used in a lot of education, is like, well, if you go to college, will that make you, will you increase the probability of finding or having a better job? Well, or to find a better job and so, but financial mobility and so. And that's an example why there is an intervention, right? Going to college is the difference from the control, not going to college, but it's not that easy to answer that. But at the end of ultimately that's the type of questions you want to ask. So the evolution of causal inference, and you might know, if you know a lot about that also, I don't want to repeat it over. This is a very brief summary to get to what I think is important for a program of social science and working with data, right? Because it's not only the data, but these models and the scientific inference that you get from data if what you're doing is research. So for causal inference, it started already in the 20s from the genetics, biology part, from Seaman and Wright with the path diagrams, from Neyman on the designing the potential outcomes framework or model. But at that time, then Fisher defining the randomized controlled trials. But at that point, it was with experimental data. So we're talking about experimental observational data. Most social sciences have observational data. It's not that easy to do an experiment in social science. It's not like in health, biomedicine, and so that a lot of the clinical trials can be done as randomized controlled trials because, you have a drug, you administrate it, you have a control group, and so you can take a randomized. And there is a process to do that, right? But in social science, you can not as easily say, okay, in this school, we're going to do, these people do that, and these people will do this other thing. There might be, governments might not allow you to do it, and there is ethical issues, there is a lot of implications. So, and this is just one of the examples, but I can give you many examples. It's hard to conduct well-designed randomized control trial, although it has been done, and there are many studies, longitudinal studies that have been done very well. But basically, using causal inference, which has the problem that you don't know the counterfactual, that you know if X causes Y, if you have an individual or an observation, then you give it this X, this intervention, right? You cannot have at the same time simultaneously the observation of that person not being given that intervention, right? So it's an essential problem, of course, of causal inference, and what that means that when case of, for observational data, that makes the problem a lot harder because you don't start with necessarily, you don't have an experiment done in nature. Sometimes you do, like you can select the data in a way that it is like a randomized control trial. But a lot of, making that point because a lot of what the interest in causal inference by social scientists increased after the 70s. You might not see the numbers here, but the 70s is when the term starts to be used more for causal inference and for counterfactual, and in part because the Rubin with its potential outcomes model for observational data, right, that publishing a book in the 70s, so started to bring that, make that a lot more wider, or provides some options for how to do causal inference when in most of the cases of social science when you have observational data. And then that followed with work from Pearl, from Judith Pearl, obviously, that has done a lot of work on the causal path or causal diagrams. And there is, I would say, almost an explosion. I looked recently because I read a lot of these books that my family used to say, what are you reading in the summer? And I'm reading causal inference. It seems very boring, but I find it fascinating. But there's been an explosion of books in this area in the last years, and a lot of. I was fortunate to have most of my colleagues that we did a weekly workshop, were the authors of a lot of these books, right? Ex-colleagues. When I was at Harvard Institute for Quantitative Social Sciences, that's one of the areas they work a lot. So, there's a lot of interesting, what I consider interesting books about this area with a lot of methodology, a lot of detailed methodology to do provide causal inference models with observational data. and you find the complexity, right, of it. With more recently with machine learning, so you obviously can now have a lot of research done in text data from applying NLP, whether it's sentiment analysis to topical classification, any type of classification or so, to help a lot with some cases with qualitative data or from structured data that can be used that way as well with feature extraction to be used in some quantitative models. But I wanted to point out also two papers from the Harvard Data Science Review, also some of the colleagues that worked on that. How we should be careful on when the ultimate pursuit or motivation is causal inference or explaining the data, right? Explaining the relationship with the variables with machine learning, AI. We need to be very careful that from the observational data and using ML has an implicit bias or confounding bias. There might be some variable. They put up, for example, one of the examples using in one of these papers is for cases where you have, for example, depression. Could be people with depression that get a dog. Do they improve? Do they get better by getting a dog? Is getting the dog the reason, right? Is that the cause effect? There you can have many confounds. So depending how you you apply the models, you could get completely the opposite answer, saying that it's not helping because usually the people that have the dog because of depression are a higher degree of depression. They have a high level of depression. So there's a confounding variable already about the levels of depression to start with. So you cannot compare directly the control and the intervention, right? Or the people that have been given the dog, because we're not talking about the same randomized group of population. So with all of this, when you do, there's the approach to use machine learning to impute the potential outcomes, the variables the data that you don't have in causal inference, but it need to be very careful in this case that you basically look at your data, how you would define a randomized control trial within the observational data. So, that a lot about models and data, how it is used in social science, and I always get afraid that maybe this is not of interest to the work that you're doing, but I think it is always important to see how are the data being used to infer knowledge, right? And how do you need to do it correctly? There are so many tools out there now that you can just download and use and try to find something about data, but there are so many ways that you can go wrong if you don't do a very careful, you don't have the subject expertise, right, of the field of social sciences and do careful causal analysis of what are all the factors that are the ones that you know and the ones that you don't, that are not there, that are not observed, right? The confounded variables that can be affecting your results. So I think that's important when then we talk about data because it's closely associated. So for open data and reproducibility, so I'll start with the FAIR principles that was one of the authors, the original group that we got together to define how should we have data that it's more easier to reuse. But one of the important parts was motivation was that not only easy to reuse by others, but easy to reuse by machines. So we're gonna do more ML, more statistical, have more tools to nowadays machine learning AI or statistical tools, any statistical tool that would just automatically use the data, they need to have enough information to understand that data, right? And how do we do, what kind of principles should we follow so that when we share data, when we put them in repositories or archives or databases, they can be reused that way. So that's how the findable, accessible, interoperable, and reusable principles were originated. For the findable, the most important thing is that, well, it has to be easy to find. But you need some metadata that helps you to identify, to find those data sets. But also that you have a persistent identifier to be able to get that data. For accessibility, so that there are the protocols that are open, right, for and commonly used for retrieving the data. And that when the data are not open, there has to be also well-defined mechanisms, right, for authorization, authentication and authorization, so that you can access that data. Interoperable, perhaps the hardest part of being fair as data, but is to have data that can be merged with a data set can be merged with another set to be able to harmonize data sets, right? And what I need to do it by having a common metadata or common taxonomies, ontologies that allow you to compare this variable with this other variable, this feature of this data with that other feature, or you can do something creative by using some AI. I'm getting that I think I need some water. A little bit, right? So that you could do that, try to automatically create similarities between one data set and another, and be able to make it interoperable. And also be able to facilitate what I was saying, that other tools that we build, right, or systems, platforms that can use data directly without so interoperate between the systems and the data, not only from a data set to another data set. And then reusable, again, a lot of it is that it has enough metadata to be reused or enough description, but it also needs to have very clear licensing or even if it's completely open, and that would be, for example, a Creative Commons 0, right, a CC0, but even that is a waiver that needs to be defined. If nothing is defined, you don't know how you can reuse that data. So with the implementation of the Dataverse, which is this open source platform for sharing data sets, for building repositories of data sets, that was first done for social sciences, but it's used now in a number of universities and research organizations for different type of research data in all the fields. So we follow well provide the functionality that would help guarantee or support these fair principles. And part of it was to give DOIs to every data set. In this case, actually, it's not only per data set, but for each version of the data set too, and for every, defining the data set as a set of files. So it could be, it's not just one file, it could be many files, and that makes sense to have them together, and that they have metadata, descriptive metadata for all the files. Usually that descriptive metadata follow some standards like, wait, I forgot to drink the water. It's very important to not only open what I will drink. Thank you. So, for these descriptive metadata, more general purpose common metadata, the Dataverse and other repositories that follow the standards like the ADBIS core, data site standards, or schema.org, right, for data sets. Also, there are other DAGs, and so But for the social sciences and the metadata use the Data Documentation Initiative, the DDI, for describing all the variables, and it provides a lot of metadata fields for the descriptive statistics on social science data sets. So it's unique for that, it's very useful. At the same time, it supports all the functionality to give, by default, a CC0, CC BY license to the data set, but also be able to construct data use agreements or other terms that conditions for reuse of the data. So then when the data are sensitive, it's more difficult. So one of the things that I've worked on also at the time at Harvard with Latanya Sweeney, in this case was in the data tax system, to be able to define a set of levels for going from data storing and transferring and sharing data more sensitive to completely open, right? You could define these 6 levels that are described here, but it could you could use that system to define only 3 levels if you would want to, right? But the thing is that there are some conditions on or requirements of how you're going to store it, how you're going to transfer it, how you're going to share the data, that all those together need to follow the legal requirements, right? Depending on where you are, right? Whether it's GDPR in Europe or other laws in regulations in other places. But then you have these labels or these different data tags that help you to that you give you assign to each file so that you know that file how it needs to be handled. This is something that together with some work with Salvador and scientists at Harvard with differential privacy also, so that you apply some level of noise to questions you want to have to the data, so that response, the statistical reply or the statistical result is differentially private, meaning that there is enough noise that you cannot re-identify any of the observation, any one single observation, right? So that's there is the project is OpenDP project that it's for differential privacy tools that are used that is starting to be used in research and integrated both these and data tags with Dataverse, so that you could provide a repository where you emphasize or encourage open data, but when the data are sensitive, you have some solutions to make it as open as possible, as accessible as possible through these mechanisms. Computational reproducible research, we also work on packaging the code and the data and the workflows, basically, that you apply of the pipeline of data processing into a package and an object that is the research object crate, that's called the arrow crate, with some metadata, wrapping with metadata, so that you can deposit that in the repository as a computational reproducible object that you could run. The same with this other paper for advancing computational reproducibility, to also being able to package the Docker wrapping it in a way that you have the data and the code and you could deploy and reproduce the results. So for following these best practices for computational reproducibility, this is based on Victoria Stodan on reproducibility, right? That would be to then share the data and code in an open trusted repository. That's why we work on this with the Dataverse to one of the trusted repositories to put the data. It's trusted in the sense that there is long-term persistent, accessible, and the data will not go any place. that they are used for system links or citations with something like UIs to publish the data and the code and cite the data and code also to provide a citation when you publish a paper, the data and code, and define the license also for the code and for your research, your scientific code. So to understand how it can be reused and to make that open, open source. For helping for reproducibility, we did a study to see from the top 50 social science journals which ones had policies that ask for the data and sometimes the code to be able to reproduce the results. So that was already a few years ago. This probably has advanced over time because there's been an increase in reproducibility awareness, right? So I would say that in political science, economics, and psychology were the fields that there was more the green and the blue. Well, the green is that it was required, the blue stuff was encouraged, but not required, right? So in those cases were the fields in social sciences that there's more awareness of reproducibility, and that's required more often. In history, is very little yet in this case. So they work more on qualitative data, and maybe it's complex sometimes to share. So the other work related to reproducibility is the pre-registration. If any of you know what registration is, it's like the Center of Open Science. Brian Mercè, a psychologist, started that. But the idea that you pre-register your study design so that the idea is to avoid cognitive implicit biases that we have, cognitive biases about having already an agenda where we're cherry picking, right? What result, what data I'm going to use for the result I want. But if you define pre-registering, saying this is how I'm going to be doing it, this is the data I'm going to use, and so and then when you publish, you refer to this pre-registration. It keeps you more honest that this is what you have designed. You cannot change it to get the result you wanted. Not with the idea that scientists or researchers in general, I think there are very few that do fraud. There are some, but those are found usually easily after some time. But it's just because of that, because we have cognitive biases, because we might even implicitly and constantly we we think we're doing it rigorously, but we're biasing towards the answer we want to get. So so now we're in the computation. After having seen what social sciences, the models and the data, type of data that are used in social sciences, have more computational, have become with more quantitative data, but also with big data, right? And the part about open data and reproducibility, then we start this new program that, as I said, is new in supercomputing centers. I think that it's very timely because social science is so relevant to many of the research that are done in almost any organization center or university, but also very much for policy making too. So for those who don't know, the Barcelona Supercomputing Center is an organization that started in 2005. It is basically the main reason why it was started is to be a service for supercomputing, for running jobs that could not be running on a cluster or your own computer or so. And it is available for free, but through applying through computing application process for Spanish researchers and also for any European research through the Euro High Performance Computing Joint Undertaking, the Euro HPC. So besides the Mare Nostrum, the supercomputer, the BSC, or the Barcelona Supercomputing Center, a very large group, 100 people, only about 100 of those are really part of the core of the operations of the supercomputer and provide that service to other researchers. The rest are scientific departments, research departments that are working towards either improving computation or working on different science areas, right, to make use of supercomputing to advance those various scientific fields. The Mare Nostrum 5, and the picture that you have here is the Mare Nostrum 4. It's visited very much from all over the world because it's in this church. Very clear, very soon, very close to here, right? Have you visited already, or? So it's impressive to, it's a juxtaposition of a church and a big machine. The Mare Nostrum 5, it's been built in on the building next to it, where my office is, but in the basement. And that one will be when it's launched this October, will be the first in Europe, with already for together about 300 some petaflops peak performance, and has a total of about 600 petabytes for data. I mean, one of the changes that has been in these supercomputing centers is that there's been, with more research in AI, that there is more data-driven or data-intensive research. There's been more increase in the storage in the data center part of the supercomputer. So it's not only computational, but you need the data nearby to do a lot of the work. So that's been increasing. So as I said, in addition to the service that is provided, there is a department in computer science that's working a lot on one of the big projects is the open source chip, for the European chip, for that hopefully will be used in the Mare Nostrum 6. Earth sciences, they're working on climate change and what they call the Earth's twin of air pollution and climate change and environmental issues with simulations. Life sciences also working on precision medicine and related topics, and then an engineering department. But the new thing is the computational social sciences that didn't exist until now. What is the vision of the program is to prepare the social science and humanities to benefit from very data-intensive age and AI, increase the collaboration between social science and computer scientists, information scientists, I should say, and facilitates also the use of these high-performance computing supercomputers to more researchers, right? So we are to open that to many other new users that are not used to this type of computational work. So we need to build also the tools to make it easier to use HPC. And then there is the part about at the end, can some of what comes out of this program be applied to assist policy making? So the program's strategy is divided in these 4 areas of what it drives it is the science, the research project, then there need to be some tools and services that help accompany the social scientists to use the supercomputer, to use computational models and so. There is a part of creating a community with a high-performance community and with a social science community, trying to get more researchers on these fields to to understand, that they can use the supercomputer, and a part of education and training. So the two research projects, this is a very new program, so there is not a lot of, that has been done, but there is for now some initial funding and collaborations on two areas, and many more that are supposed to come in the I cannot speak about it yet because the funding is not here yet, but that are going to come hopefully during this year for 5 more projects. But these two ones we're going to get started now already in the fall, and one is related to demographics and to data and populations. The data in this case is from 155 countries, a lot of the statistical, the census data and surveys and other statistical data from all these countries, but to study how the households are changing over time and what they cost, what are the different variables that makes it change. The structure of a household, if years ago you would find 3 generations living in one place, now in many places in Europe, most of the house in big cities is one person actually. So there's a huge change that has a lot of implications in policies, in cities, in urbanism, in many socioeconomic issues, right? These are studies to see, to do this descriptive inference using a multi-level regression model with a lot of data that exists now. Now a lot of that data that just using 5% of the data that they have in a cluster from the university, it takes them a week to be able to do the processing. So they obviously with the supercomputer, it's a good example that would speed up that, but also it's complex from the point of view of creating the model that can give us that how this changes from rural areas to other, from country to country, from one area of the country to another, etc. Right? With many variables. So this is one of the words. Now mentioning this about the speed of the supercomputer. The Mare Nostrum 5 will be equivalent to, if you compare like 100 years of running something in this laptop, it will be done in 1 hour, right? So the difference is quite impressive. Of course, you need to know to do it in parallel, using HPC. I mean, you could do the same job running it in a way that doesn't give you that speed. But so the other project is large language model, create a large language model for social sciences. With training it with a lot of data from social sciences, from all the laws in the world to many data sets that it can use to train the data. And the idea is also, this is with Harvard and with the Institute for Computational Social Sciences, and the idea is to also create an LLM that so completely real open source, not like OpenAI. And the data set is also open, that is used for research, that is responsible, that it has, that they use it is well understood and with some traceability or at least some way of assessing the value of the results, and so that it can be used for science. So these are the project. I'm just almost finished the first the program. Also, as I said, there is one part of services and tools that we want to build for the program here in Spain. The Barcelona Supercomputing is 60% basically funded by the Spanish government, 30% by the Catalan government, and 10% by the university that we have now, right? So, but within all of Spain, we create, as part of that program, a repository for social science data. There are some data sets, databases out there and so, but create a place where we can find a lot of the research data and share more data to have more access access or make it easier to do computational social sciences. We're going to integrate the repositories with the supercomputing, make it easier building the workflows that help you to run data, do some modeling in HPC from those data sets. Then also explore ways of using AI to create common data, metadata across those data sets. And also test the sensitive tools that I talked about, OpenDP, data tags, and so for doing research, a lot of the social science research similar to biomedical class data has privacy concerns or sensitive, so we can do research on those in a responsible way. So this is part of the future services that I would hope that the program will provide, and the need of a social science data repository in Spain. I mentioned earlier for some of those data archives, and so that there is the CES, that is Consortium of Social Science, and it's an ERIC in Europe, right? One of the research infrastructures in Europe. But Spain is not part of it yet, so one of the things that I'm working from the program is to make that, Spain part of it and provide fair social science data for research, basically, in these fields. So conclusions. Hopefully I didn't bore you too much. You're finishing and we have time for questions, I hope. So we're setting this program, but in the context of thinking about data and about science. I would say the summary that, data are key to that success of computational social science and to the advance of social sciences, of being able to learn about the world. And we need to do that responsibly, and so we need to have repositories that have more access to good quality data, right, for research. And that's one of the things we're planning to do with the program, following these FAIR principles for machine and human actionable data. But then not forget that the science is the goal, and that we need to see. So at the end, what we want is to make descriptive and explanatory inferences, right, from the data, from all the empirical evidence that we can get. And ultimately, I would say not everybody agrees with that, but I think that even though descriptive inference is very important, describing how the world is, but understanding how it works is even more, right? So I think causal inference is also very important for anything in social sciences. I think we all do using it well with observational data, with machine learning, with AI is very complex, and we need to be very careful how we do it, but doesn't mean we shouldn't do it. So it is very important, but if we start with good quality data sets, or describe data sets, and understand how do we need to do the analysis to be as close to be as analog to what we would do if we had a randomized control experiment, right? Trial to be able to understand the causality. And at the end, open, explainable models, and open code, open source code to make reproducible research and reusable research. Thank you.
Thank you very much. So it's time for questions. I'm going to use the mic, which is here. So, questions. Please. How do you know how to use it?
And thank you for this great overview. So you mentioned that you want to fundamentally at ADBIS build services for computational social sciences. How standardized are the actual workflows people try to execute in those workflows? I could imagine that for this particular field, writing a parallel MPI program is just not the right abstraction level. But if it's somewhat standardized, there's common practices that you could actually apply this as a service. So how how standardized also is complex workflows?
Right, right. And you mean how standardized they are now, or how standardized we want to? Yeah, well, so in social science, so this part of the services, I mean, it's still in a planning phase. So what we do with Rosa Badia, I think that you had the keynote earlier this week. So with her team, using the workflows that they're using it, but what we want to do is to have use cases in social sciences to see how are they easier to, so is there a layer on top of those workflows that would facilitate the use, they use not only the layer on top to facilitate, but also that it uses the models that are commonly used in social sciences, so that maybe now they have created the workflows for some analysis of some data processing that is not the most commonly used in social science use cases because they haven't had many use cases. So it will be a lot driven by use cases for real social science projects that we work on as part of the program on collaboration with others. And based on that, want to build those workflows. It maybe go even beyond the workflows, maybe some tools or web interfaces that are a little bit more intuitive about how to use the supercomputer instead of going command line. I mean, this is again lowering the bar for more users that are not in that in a computational field to be able to use that. Of course, often they will be done in collaboration with people in our teams in the BSc. But that's the idea.
Thank you. More questions?
Well, thank you, Mercè, for the interesting talk. So my question is related to data and to data quality. So how do you define quality for data for social sciences? And second, the more specific question, so I'm wondering whether issues related to data incompleteness are taken into account in the processing pipelines.
Yes, very much.
Or is something outside the processing pipeline because your data sources come from some alternative. So you don't have such kind of problems.
Well, no, very good question, but it's not. I'm sure that there can be many answers about quality of the good quality. I think a lot of it, in some way, we find those fair principles to help follow some criteria about things your data should have that will help you at least being able to well, it's more structured. If it has metadata, somebody has had to spend some time understanding what the data includes, right? So I think that at least for me, the quality is not only about the completeness of the data, because it's just a lot of times that's not possible. It's more about how well understood and described it is. So and that's why I put this emphasis on all the semantic artifacts that go around the data, right? But in part because so it's more important to understand how this variable was collected and the limitations and any errors, and so that the fact that it's perfect, right? And yes, in social science, well, with the art libraries that are built, there is a lot of community that are using art and community that is using Python, but in a lot of our libraries, there is the topic of missing values and imputing imputation of value of the missing values by understanding the averages of the rest of the data set. It's essential to the cleaning of the data. As we know, a lot of times you spend 80% of the time preparing the data set and then actually running the regression of the machine learning model or anything at the end. But I think this 80% of the time, so or 90, this is what converts that into a data set that is a good quality, that you can work on it because it has filled out the missing data, it has filled or done or removed observations that you cannot use, or that that you understand every feature, how it was obtained, and what are the limitations of what it is, and so I would say, if I had to summarize, a well-described data set that is understood, that can be understood by somebody who has not created the data set, that would be a good quality data. And most of the time when we find it on the web, that's not the case. But we can convert it into that. And what I try to emphasize with this data sharing and the repositories is that once we've done all this work, why not sharing again the data set that is better quality now because it's better described and so on.
Thank you. One question. I have a question, but probably from Howard. Of course, creating metadata for the data and having this understandable representation also on the conditions in which you have cleaned the data and produced a usable data set is important. I was wondering what about the pipelines? Sometimes people that are not quite used, for example, when you start using machine learning, etc., are kind of anxious of which were the conditions in which the results have come. And then, what is your opinion about creating metadata for the pipelines in order to share this also?
For the workflow
Right,
itself.
exactly.
Yeah, just in some way the research object, right, this project that is with people in the UK, in the University of Manchester. Yes, Carol Goebel. So, well, part of it is also having that metadata for the workflows themselves. I think it is very important. I mean, for the pipeline, what you do, even if it's a Jupyter notebook that you explain the steps on the pipeline to be able to reproduce, well, even if it's not reproducible in the sense of verifying the research, but even for yourself and another time understanding all the, well, even just describing that as metadata, as you know, often helps you to find the errors in what you're doing, right? So I think it's essential. So I think it's true that we've been emphasizing a lot about data, quality data, metadata data, but that's what I wanted to talk quite a bit about the models and the code because methods and so, because at the end, all these, we need to apply all this to that too. I mean, the two go together, right? When you're gonna use data, you're gonna process it somehow, and you're gonna use some code to do so. Think of all of it as that object, that the objects that you use, the digital objects you use to do your research, or to inference, or your analysis, or this. And yeah, so I would apply it the same to the pipelines and to the code. It just made me think though that because related to the data quality with the code. I mean, ideally, also this data quality starts at the design, at the research design. If you're designing it a good study, and it doesn't need to be experiment and observation and so, but what are the questions you're gonna? You're already based on if you define it based on those questions, right? And you have been thoughtful about all the relationships and all the factors that can. How to answer that question, you will get a data set that is more appropriate for what you want. Even if you do, what you're getting is data, big data, but from there, thinking about what is that you're questioning and design the subset of data that is going to be useful for you, what is missing and what is biased, right?
Hi. If I understood, this is an environment that you can save, share, and process your data. Is this correct?
For the data, the one when I talk about the platform for data sharing, you mean?
Yes.
Yeah.
Specialized focus on the social science.
So the platform itself, the data can be used now for any data.
This is my question. So
Yes.
anyone can use this and how it works.
Yeah. So if you go to Dataverse, or there is a whole community. I used to lead that project. I don't now, so I don't speak for, not for me, but it's for the, because since I started this new thing now, there is somebody, a great a statistician that it's leading the project. It's dataverse.org, and from there you can download the open source code. There is, well, quite a bit of configuration because you're building a platform that will help you create many repositories, right? But there is a pretty large community now worldwide that are using it and they're developing and improving it, and that they're now doing an interesting architecture change to have, well, almost all of it that you can do with the functionality from the web application itself, you can do also through the APIs. So it's a RESTful API, and you can build a lot of tools on top that are plugins of the platform, and for different types of storages for the platform. Yeah, I could have given a whole talk on that because it's a work, but well, always there are many topics.
This means that eventually we can have another one. I just want to have a last question before we close the session. Of course, when you work on transdisciplinary projects, and particularly you coming from physics and then moving into social sciences, etc., there is a big bunch of education to be done. And so maybe it's not a question, but a suggestion. If you could somehow or somewhere share which would be the kind of books or the kind of path that someone could do. Yes, exactly. If someone is interested in dealing with social sciences, and of course eventually others dealing with other sciences, so to to see that it's important to be educated.
Yeah, yes. I have to say I was very fortunate because in my transition I was for almost 20 years in an institute that I was surrounded by many of the quantitative computational social scientists that have, in many cases, have been the pioneers of all the new modern methods, and so applied methods for social science, and I learned very much directly from them. I mean, first you need a very curious mind to learn, right? Which is, I think, a good thing in general. We have if we're here, right? Yeah, I mean, I showed several of some references and showed some of the books here, but that's why I showed several related to causal inference, because at the end it is not only about saying, well, learning the mechanics of running this model, doing this, but is what motivates the questions that are done in social sciences. So a lot of these books have examples of what kind of questions we are going after, and how do we do a very rigorous analysis, what type of data we need to use, and what do we do with the data to be able to answer these questions that explain, right, there is the why is this happening, and what is the cause effect. And I think those maybe are the more complex of all the ones you could start with. If you want to start with one easier one, this data analysis for social science and designing social inquiry, I recommend. But then all of those other ones too. But the thing is that, like in many other fields, you're constantly learning. I mean, I like to believe that I also brought some part of what how I was trained as a physicist to social sciences, because it came at the time of more, they say reproducibility crisis in psychology, in economics, in all these things. But in physics, often that was something more understood. It doesn't mean that everything that is done is reproducible, but the fact that it had to be, in astronomy too, but the data are open and the code, and that we just having one result doesn't mean, one paper is not a conclusion, right? You need to validate it with many, reproducing that same paper, or replicating with new data also. So all those things were also a good thing. But yeah, I think from my talk, which I'm happy to share, there are a lot of references. And I think it's fascinating always to learn other fields. Happy to continue learning. So.
Well, thank you very much. It's time to thank for your time and your talk.